And we're back. We were able to deploy a smart contract. We have the smart contract on public network, on Matic. So on Polygon, we can see the contract on Polygon scan. We verified it, so you can read and write to the contract directly here, which will be useful for debugging. You can read the entire code. You can copy from it, by the way, but I'm going to provide you with the direct contract source code. Inside the repository, there will be a folder called contracts, and you can just copy from them directly, no problem. Yeah, so let's do read and write. Let's go to our game and let's start interacting with the contract. So first of all, we need to have some point of interaction that we might to do it inside the menu, but let's say that we want to have like a vendor or something. So let's make let's make a small vendor place. So let's get a yeah. So this is from engine and this is from static mesh. Okay, yeah, we can just get this. Let's make it like 0.2, 0.2 and 1, no problem. Move it here, here. Let's add a box. No, it's a cube, our favorite cube. Okay, shape cube, come here cube, you're going to be a table now. No, 0.5, yeah, 2.1, beautiful, you're going to be a table, come here. Okay, you're a table, that's great. And let's make an actor. So let's go just here into blockchain blueprints. We got those blueprints. Let's create a new blueprint class. Just make it an actor. It doesn't have to be a pawn or anything. So an actor and call it b_color vendor. And inside color vendor, let's open it up. Inside color vendor, we want to get okay, mannequin, but we want to have just the mesh physics asset. No, where's the okay, this is the skeleton mesh. Okay, let's make it queen simple. Let's go here, add a component. Okay, queen simple. Let's make it the default scene root. Let's make her play single animation. Just play idle. Okay, so she's playing idle, looking this way, and want to add, let's say, a trigger box. Box collision, perfect. So let's put it like in front and let's make it like 50 by 100 by 100, and let's put it here. So if you stand in front of her or next to her, you will be in this box. And now if this box let's see, it's collision settings, collision, yes, overlap all dynamic, generate overlap events, that's good. Does it overlap pawn? Yes. Okay, so event graph, add event, on component begin overlap, and we need on component end overlap. So on begin overlap, we got this other actor, we want to cast to character just to see if it is a character class. And when we have, this is C++ class, so this class is very cheap. They want to see if this class player controlled, because we don't care for AI at all. If it is player controlled, then great. We want to see authority, and we don't care for authority. We want this to happen. You know what? We want this to happen only locally, but local can have authority if we are playing standalone. So we don't care for that at all. So if it is player controlled, get controller, and want to cast to player controller. And once we cast to player controller, we want to set mouse, show mouse cursor, and want to enable mouse cursor. And because we already done functions on mouse cursor inside the third person character, when we show mouse cursor, it stops swinging the camera left and right. So this is that. And once we end overlap, we want to do the opposite. So other actor on end overlap, show mouse cursor, no. Okay, but here we also want to do one more thing. We want to add a widget, and with this widget we're going to have interactions with. So we're going to blockchain UI, and we're going to add a new widget, user interface, widget blueprint, and user widget. And this user widget will be called UI color picker. So we got this color picker, and we open it up, and we want to first of all add a canvas panel, because yeah, we want to have this. And this is just screen size canvas panel, and inside this canvas panel we want to have basically another canvas panel, or how did we let's look at the wallet widget. How is this being done? So this is border, and then this is canvas panel. Let's do it the same way. Let's just do a border, and let's put this border, anchor it to the middle, 0.5, 0.5, 0, 0. Let's make it like 400 by 400. That should be enough. Okay, it fills the entire space. I'm sorry. Excuse me. Okay, content, color, and opacity, we don't care about it. The appearance of the entire thing goes like black, but 0.8, so it's just light transparency. And we can copy from this actually. So here we didn't padding, just 5. Let's do the same padding, just 5 all over the place. And let's do canvas panel inside it. And inside this canvas panel we're going to just, it's filling everything except for the borders that we set. So inside this one we're going to set the color picker. So we need a color wheel. So now color wheel is from a plugin. And this plugin is forever free. Anyone can just download it, add it to your project. It's called Color Wheel. Simple as that. And it has few helper functions. It will just make our lives a lot easier. We don't have to pick colors by hand, because we can just drag it here, drop it here. And we can now say, okay, anchor this here. And position is 0. And it's 0.5, and it's 0. So size is 360 by 360. Okay, that's too big. 320 by 320. Okay, that's a lot better. Okay, and we just got this color picker, and it is a variable. This is important, and we need a button, and we're just adding a button, and this button is going to be anchored on the bottom of this at 0, 0. This is 0.5. This is 1. Yes. This will be 200 by 60, no, maybe 50. Okay, background color will be like a lot darker. I like it this way, white text. And we need to add a text, and this text is static. Just claim color. And this button will be called button underscore claim color, and it is a variable. Okay, so we got this widget, and all we want to do now is when we go close to this, we want to create widget. Okay, let's do it properly. Custom event, show widget, and we want to have an input which is show, and we want to do it like this. So if show widget is true, we want to create this widget color picker, and we want to promote it to variable color widget, and this color widget is being stored, and when it's being stored, we want to add to viewport to player screen. That's even better. Player screen is for split screen. It adds to specific player, not to the entire viewport. That shouldn't be, I mean, we don't plan it to be split screen, but it's just good practice to use player screen instead of viewport. Owning player can be empty, so this is basically get player controller 0. And it's no longer split screen. Doesn't matter. Okay, so this is creation of it, but we might have a situation where it already exists. So let's do this. Convert to validate get. So if it is not valid, then please construct it for me and add it to viewport. But if it is valid, I just want to see if it's in viewport. And if it is in viewport, then don't do anything, because we don't want it to be twice in the viewport, because you can basically have multiple of those color pickers. But if it is not in a viewport, what you want to do is to add to player I swear to God, I'm making the same typos in all of the functions. Someone can read my code and know that I created just by the typos. So if it is not in viewport, then add it to viewport. However, if you want to hide it, you need to know if it exists. So if it's not valid, it doesn't exist, that's great, we don't have to do anything. If it does exist, if it is valid, then we want to see if it is in viewport. And if it is in viewport true, then we want to remove from parent. Okay, so this is widget toggling. This makes sure that if we have the same widget like multiple times, we act on it based on the state, not on the state that we assume we are at. So the actual state that the widget is in. So now having this function, we can show widget locally true, and here will be show widget. It's a local function, show false. Let's test it out. Oh, and let's put our blueprint color vendor, let's put her here, and she's selling colors to anyone who comes near her. Okay, let's hit play. Okay, I got this. I can make contact with it. can drag it, I can click this, it does nothing. If I walk away, it disappears. This is exactly what we wanted. Okay, so now we got this. Okay, so let's connect this button that we created inside the widget color picker to actually do something. And we don't need anything more from the vendor because all the interaction will be happening on the blockchain level. There is no interaction that is required from blueprints anymore. Everything will be handled on blockchain that will be called from the widget itself, which means that you don't really even need this vendor to run this function. You could not even be logged into the game and still interact and claim colors outside of the game or from a different game. Let's say that you have a mobile client that allows you to make customization of characters only. It does nothing else, and it can customize any character, and you can read the customization values here in game afterwards. And that's actually something we're doing in a small project that we're working on right now. But yeah, no spoilers. So we got this. Okay, let's go here, go to this button, go down, unclicked. This is what we want. We don't need, do we need anything here? Pre-construct, definitely not. Tick, definitely not. We could fetch our information from a different object, but we are storing our wallet information inside save game objects. So we created a library and we can do read wallet read. The common name is wallet, and unsuccessful, we got the key and we are storing it now locally inside this widget. And we can just call it wallet key, that's fine. And we need our address, so public key. And if public key generation is successful, then we want to generate address, generate Ethereum address. And if Ethereum address generation is successful, I'm not going to do debug strings because we never had an error. We want to say Ethereum address, okay, just wallet address. Okay, so in order to interact with specific contract, we need to go back here and we need to copy this contract address. So just copy it. Thank you, don't need you anymore. Create a new variable and call it contract address, and let's make it just a string. Compile so I can put default, and this is the default value. Yeah, I'm not changing that. None of this have to be instance editable. This is okay. Okay, so let's do the claim of color. So this is the more complex operation. Reading from a contract is a lot easier than writing into a contract. So first of all, we need to construct ABI. We need an ABI object. So we want to parse ABI from JSON. Now, how to get this ABI? Very simple. We go back to this contract. We go to contract code, and here we have contract ABI. Just copy to clipboard. Awesome. Got it. And just paste it here. And this will create the proper object. And when it does that, you know what? We even don't have to do it here. We can do it on begin play because we can do it just once. And we can just promote this to a variable and call it contract ABI. That's actually the name I would call it, and just store it. So this is construct ABI object, and this is init wallet, and this is begin play basically, and this is on claim color. Okay, so when we are claiming color, something needs to happen. we have this ABI we encoded. So now what we want to do, if we go back here, we want to call a specific function, right? We want to write contract and call this function add color with a parameter underscore color. So we got one parameter and one function we want to call. So we need to copy this name, right? It's okay, add color, can drag it there. And now we need to parse ABI from JSON, okay. And now we need to encode ABI. So when we click, we are doing a set of functions. First, we are encoding ABI. This is the ABI we are using, an object. The function name is add color. Capitalization is important. And we have one argument. So we need to construct a new array and implement one argument, which is the color. We don't have the color yet, but we're going to have it in a second. And once we succeed, we are getting this function hash and encoded argument. And we can push it directly to the next function or whatever we are doing next. Or we can store it as a variable temporarily in case that someone clicks the button like too many times. But let's use it directly. So what we need to do now is sign transaction, but before we sign transaction, we'll need sign transaction, we need it send transaction, and we need estimate gas. We need those three functions to run in consequence after each other. So first of all, we have this information now, and we need to know how much will it cost us to push this data into the contract, because the more data you are pushing, the more expensive the action will be. And to operate on this, we also need to have, we're going to prepare stuff first. So we got our wallet address. We need to do what we already did in previous. So we need to get transaction count, and we're going to say, you know what, let's store this config on begin play as well. So we can change it somewhere later if we want. Promote to variable blockchain config. Okay, great. Okay, let's use it here. So let's just get this split URL ID non-address is our wallet address. Latest on success, we want to create a variable called nonce. Oh, it's created transaction count. Okay, nonce. I want it to be called nonce. Not from here, but from here. Q. Okay, we got nonce. After we got nonce, we need to get gas price. Something we already did in previous tutorials. And again, it's the same URL as we used here. No ID, unsuccessful, on completion. We want to get gas price. Okay, so we got gas price now. And this is basically, I'm going to collapse this. Oh, let's first connect it here. And now I can collapse those nodes. And this is prepare variables. Those are basic variables required to just send transaction. Then we are encoding the ABI. And from this we get arguments. So basically from address is our wallet address. To address is the contract address. Data is this data. So let's promote it to a variable. Let's call it data. So if this is true, we are storing data and we are reading this data directly here. And the URL is our blockchain config. Oh, again, I'm clicking too fast. I already got this. Split, get the URL. I hate when they cross, but so be it. When this is completed, we got this estimate gas. We promote it to variable, save it as estimate gas. Not from here, from thru, only on completion success. If something fails along the way, we are stopping the execution of the entire function. That's the way you should do it. Now we need to sign a transaction. So now we are using the wallet key that we have provided. We have the nonce that we have provided. We have the gas price that we queried from the network. And we have estimate gas, which is the gas limit. To address is the contract address. We don't have to specify from, because from is being get from this wallet basic. Besides, yeah, we are sending this transaction to a contract, and now data is our data. Value, we need to make value. We can make literal from string 0, no problem. Value is if our function is payable. So if you have NFTs that requires payment for minting, then you can specify value that has to be at least the value of the minimum specified in the payable function, but it can be above it. And chain ID we need from our blockchain configuration. This is the chain ID, non-deterministic like last time. And once we have succeeded and completed, we get the transaction, signed transaction hash, and message hash. We need signed transaction to push it at signed transaction data. We are taking again same configuration, so I can just reuse it. And we are pushing this, and on success, I want to print text format. I want to say transaction was a success. ID. So this is the success and this is the transaction hash. So if true, print this and print it in some nice color like, I don't know, yellow. And if it is failure, then break the response and just get the entire body and print it in red. Okay, I can just use print string in red. Okay. Yes. Okay, so let's go through it once more to explain exactly what is happening here. So we're getting the nonce and actual gas price from the network. This is first thing we need to just do for this wallet. We don't even need to get the balance. It's unnecessary for this kind of transaction because it's not payable. Then we are getting the ABI that we constructed here from a JSON. And we are encoding function name @color and function arguments color. And now we need to provide this. Say success, true. If it's true, then we are storing this data. This data is being used to estimate the actual money required to process the transaction. And once this is estimated, we are storing this value and we are constructing the signed transaction. Once the transaction is signed properly, we are just sending it to network for execution. Once it is executed, we just do a print. So now how to get this actual color? It's very simple. We go to this color picker and it also has events. And on color changed, let's add it. We have new color. There's a color which is a linear color. We can do it to string by linear color, or we can do linear color to hex, and this is exactly what we're going to do. And it is not super RGB. And we're going to promote this to variable and say color as string. And this is what we're going to actually save. And print string, we want to say this color. And you know what? We can even say to print it in the color that we picked. So let's test it out. This is picking color and storing as a variable. And here, color as string is going to be pushed as string to our variable. So let's see if it works. We go here, we get our mouse, we are no longer rotating, and if I click any color, we get printout in the color that we are picking, which is pretty cool. And we see the hex code of this color. Okay. Okay, and now we can also claim this color. So you know what? Why not? Let's do it. This is our wallet. We got 2 transactions on it. We got 1 Matic. This is our address. We are going to conduct a transaction here. So let's pick, let's say this pink, because why not? And let's claim it. Okay. Transaction was successful. And it should get executed. And we should see an update, but you know what? It might cost us so little that it's not being shown in this wallet. So let's increase the number of zeros here, because I think we are rounding too much on the wallet. Let's go here. Let's go to blockchain, UI, wallet. Let's go into balance. Let's see this. Okay, wallet balance as string. Find references, and here we are setting it. So minimal fraction, maximum fraction is 6. Let's make minimum 4 and maximum is, well, 18. Compile, save. Let's try it again. Let's go here. Okay. Pick any other color. Let's go here. I still don't see any change. Okay, I am here. Okay. Let's try this one. Okay, this didn't went through. This one. Okay, so something is not fully okay here. Let's go through this, that. Let's print out the body always. If it's true or false, doesn't matter. Let's just print it out and see what do we get in return. Because we might be doing undervalued transaction, probably. Let's pick something, claim color, okay. Replacement, interesting. Okay, we can go to the contract and we can actually check it out, or we can even go to our wallet, copy the address of it, and we can go here. We can open a new window, go to our wallet. Okay, so this is still pending. It didn't happen. Why was it? Is it underpaid? Max fee. Okay. I mean, this is pending. Here we can even see our color. Here we can see the encoded inputs. So this is the idea of the method. This is the function. It's still pending. It's probably undervalued. What did I do wrong? Gas limits. This is in Vey or Gvey. Let's see. If I go to any other transaction, we got 21,000. So this is the limit. And here, I mean 66,800. That looks like a solid limit. So this should execute. I think this transaction is just undervalued. Let's go back to the wallet. Let's run our you know what? We can even we have the estimate gas. We could increase it by some very small value just to make sure that we go into a priority. So we can, for example, multiply it by a string. Oh, but this should be an integer, so let's not. Let's not multiply. Let's just add string, and let's add just small value at least, and let's store it at estimate gas. So this will increase the gas maximum spending that you are willing to spend on a transaction. But if you spend less than that, then the overhead is being returned to you. So let's see if this helps. Because if I go here, okay, let's run to her. So let's see, what's the gas price right now? So this is showing me 31, and this is the average that the network is giving me, but the actual right now is 36, so it's a lot higher. So let's try to claim I don't know, like a yellow color, and let's try it again. Okay, and this time it did execute immediately. So now if I go back to Block Explorer and I update this, I can see that the previous transaction got finally executed, and the new one as well. And the new one was a bit more pricey than the previous one. But in general, they both were. This is like tenth of a cent, and this is 2/10 of like 2 promils. That's really not a lot of money to execute something like that. But let's try it again without the increase. So let's go here. Maybe I'm just whining. Maybe this estimate gas was working correctly, and we were just very unlucky that there was a lot of transactions going through. Probably. So it didn't get properly executed. So let's make like a blue. Or more bluish. Claim. Yes. Okay, and let's see if it executes. Oh, I can check here. I think it did change. So let's go here, update. Nope, not yet. You can see transaction count 5. Yeah, like because some of those are inputs. So this is 1, 2, 3, 4, and this is a fifth that is waiting to get executed, and there it is. It was just not showing, it was already executed. So now we have 3 colors, right? And we can go into our contract. Wait, we got contract here. So this is our address. Let's copy the address. Let's go to the contract, and we can now go in and say read contract, get colors of owner. I can specify the owner. I can query, and I got 3 string values. So it is already working. Now we need to just read those values and use them inside the game. I'm going to show you how this all works together as a final product.